Hello my dear students, this is the second lecture of mechanics of solids. In the previous lecture, we have discussed some basic terms regarding mechanics of solids, and first term is stress. What is stress? It is the resistive force generated per unit area, which is known as stress induced in the member. Okay, resistive force generated per unit area, which is known as stress induced in the member. Then what is unit of stress? What is the unit of force? What is the unit of load? That is Newton. And what is the unit of area? What is the unit of area? That is meter square or millimeter square. Meter square or millimeter square. Therefore, what is its unit? Its unit is Newton per meter square. What is the unit of stress? That is Newton per meter square. And the unit of stress is Newton per meter square. Okay. This 1 Newton per meter square, it's important. 1 Newton per meter square is equal to 1 Pascal. Have you heard about this? 1 Newton per meter square, that is equal to 1 Pascal. Okay, next important one. Kilo, which is represented by K. Kilo, which is represented by K. That is mega, which is represented by capital M. Giga, which is represented by capital G. What is kilo? Kilo means 10 raised to 3. Mega means 10 raised to 6. Giga means 10 raised to 9. Okay, you have to remember at least these three terms. Kilo means 10 raised to 3. Mega means 10 raised to 6. Giga means 10 raised to 9. Then 1 kilopascal. That is 1 Pascal is equal to 1 Newton per meter square. Okay, 1 Pascal is equal to 1 Newton per meter square. Then 1 kilopascal is equal to, kilo is equal to 10 raised to 3. That is 10 raised to 3 Newton per meter square. 1 megapascal is equal to, mega means 10 raised to 6. 10 raised to 6, Pascal is equal to Newton per meter square. Newton per meter square. Okay, 1 gigapascal is equal to, giga is equal to 10 raised to 9. That is Newton per meter square. Okay. That is the important conversion. That is equal to kilopascal, megapascal, gigapascal. Okay, one more important conversion. That is 1 Newton per meter square is equal to 1 Newton per meter square is equal to, that is 1 Newton divided by meter square. Okay, that is equal to 1 Newton divided by 1 meter is equal to 10 raised to 3 millimeter. That is 1 meter is equal to 1000 millimeter. Okay, that is equal to meter into meter. That is meter square is equal to meter into meter. That is equal to 1 Newton divided by meter into meter. 1 meter is equal to 10 raised to 3 millimeter. Another meter, that is equal to 10 raised to 3 millimeter. That is millimeter into millimeter. That is millimeter square. That is meter into meter can be converted into 10 raised to 3. 1 meter is equal to 10 raised to 3 millimeter. 1 meter is equal to 10 raised to 3 millimeter. That is 10 raised to 3 into 10 raised to 3. That is equal to 1 into 10 raised to minus 6 Newton per millimeter square. That is 1 Newton per meter square is equal to 1 Newton per meter square is equal to 1 into 10 raised to minus 6 Newton per millimeter square. Okay. Then 1 megapascal is equal to 1 into 10 raised to 6 Newton per meter square. Okay. 1 megapascal is equal to 1 into 10 raised to 6 Newton per meter square. That is 1 megapascal is equal to 1 into 10 raised to 6 into Newton per meter square. That is Newton per meter square is equal to 1 into 10 raised to minus 6 Newton per mm square. That is equal to 1 into 10 raised to minus 6 Newton per mm square. Okay, that is Newton per meter square is equal to 1 into 10 raised to minus 6 Newton per mm square. That is cancel these terms. Then 1 megapascal is equal to 1 Newton per mm square. That is the important conversion in mechanics of solids. That is 1 megapascal is equal to 1 megapascal is equal to 1 Newton per millimeter square. Okay, that's 1 megapascal is equal to 1 into 10 raised to 6 Newton per meter square. That is 1 into 10 raised to 6 into Newton per meter square is equal to Newton per meter square is equal to 10 raised to minus 6 Newton per mm square. They cancel these terms. So that is 1 megapascal is equal to 1 Newton per millimeter square. Okay, that is 1 megapascal is equal to 1 Newton per millimeter. Another important conversion is that is 1 gigapascal. That is 1 gigapascal is equal to 1 into 10 raised to 9 Newton per meter square. Okay, that is equal to 1 into 10 raised to 3 into 10 raised to 6 Newton per meter square. Okay, 10 raised to 3 into 10 raised to 6, that is equal to 10 raised to 9 Newton per meter square. That is equal to 1 into 10 raised to 3, 10 raised to 6 Newton per meter square. That is 10 raised to 6 Newton per meter square, which is equal to 10 raised to 6 Newton per meter square is equal to 1 megapascal. That is equal to megapascal. That is equal to megapascal. 10 raised to 6 Newton per meter square is equal to megapascal. That is equal to 1 into 10 raised to 3 megapascal. That is 1 gigapascal is equal to 1 into 10 raised to 3 megapascal. That is 1 megapascal is equal to 1 Newton per mm square. 1 megapascal is equal to 1 Newton per mm square. Therefore, 1 gigapascal is equal to 1 into 10 raised to 3 Newton per mm square. These are the basic terms regarding engineering mechanics. Also, these are the basic terms regarding mechanics of solids. Okay, is it clear? Okay, 1 megapascal is equal to 1 megapascal is equal to 1 into 10 raised to 6 Newton per meter square. Newton per meter square is equal to 1 into 10 raised to minus 6. Cancel both times. Then 1 megapascal is equal to 1 Newton per millimeter square. That is 1 gigapascal is equal to 1 into 10 raised to 9 Newton per meter square. That is 1 into 10 raised to 3 into 10 raised to 6. That 10 raised to 6 is equal to megapascal. That is equal to 1 into 10 raised to 3 megapascal. That is 1 gigapascal is equal to 1 into 10 raised to 3 Newton per millimeter square. Okay. Okay, that is the important conversions are that is 1 pascal is equal to 1 Newton per meter square. 1 megapascal is equal to 1 Newton per millimeter square. 1 gigapascal is equal to 1 into 10 raised to 3 Newton per millimeter square. These are the important conversions of strength of material. Okay, you have to see this video repeatedly. If you have any doubt, please ask. Okay, is it clear? What are the unit of stress? Okay, now you have to know what is the basic difference between pressure and stress. Have you heard about this? What is the unit of pressure? That is Newton per meter square. That is Pascal. What is the unit of stress? That is Pascal. Then what is the difference between pressure and stress? What is stress? It is the resistive force generated per unit area. That is the resistive force generated inside the body. That is the internal resisting force per unit area, which is known as stress. What is stress? That is the intensity of internal resisting force developed at a point. We know that what is stress? Stress is the resistive force generated per unit area. That is the internal resisting force. That is the internal resisting force. This is important type. Internal resisting force. Okay. Then what is pressure? This is the same definition. That is intensity of external forces acting at a point. That is the intensity of external forces acting at a point. This is important. That is intensity of external force acting at a point. External force acting at a point, which is known as pressure. That is intensity of internal resisting force developed at a point is known as stress. Generally, pressure is dealing with the fluids. In the case of fluids, that is liquids and gases. Generally, stress is dealing with, in the case of material, that is solid members. It is in the case of solid member. Okay. Second point. Okay. Pressure is acting always normal to the surface. Normal to the surface. That is, pressure is acting always normal to the surface. Pressure is acting always normal to the surface. That is, consider a body. Consider a body. Pressure is acting always normal to the surface. That is the external force acting in the member. Always normal to the surface. but stress may be either normal or parallel to the surface, that is the shear stress to the surface. I will explain the concept of shear stress in detail later on. You have to just know what is the difference between pressure and stress. Okay, what is pressure? Intensity of external force acting at a point is known as pressure. Intensity of internal resisting force developed at a point is known as stress. Okay, pressure is occurs generally in the case of fluids. Stress is occurs generally in the case of materials, that is metals like that. Okay, pressure is acting always normal to the surface, but stress is acting either normal or parallel to the surface. Okay, third one. Pressure can be measured by measuring devices. We can measure what is the value of pressure acting in the member using pressure gauge. We can measure the value of pressure acting in a member by using the pressure gauge, the equipment like pressure gauges. Okay, but in the case of stress, we cannot measure the value of stress. We can calculate the value of stresses by using Hooke's law and other equations, but we cannot measure intensity of stress. We can calculate the value using Hooke's law and other equations, but we cannot measure. Okay, but these are the important difference between pressure and stress. Both the pressure and stress having same units, but there is a large difference between. The huge difference between pressure and stress. Pressure means intensity of external force acting at a point is known as pressure. Intensity of internal resisting force developed at a point is known as stress. Okay, pressure occurs in the case of fluids as liquids and gases, but stress is occurs in the case of materials or metals like that. Okay, pressure is acting always normal to the surface, but stress is acting normal or parallel to the surface. Pressure can be measured by using pressure gauges. Okay, but stress cannot be measured. It can be calculated by some other means. Okay, this is the difference between pressure and stress. One of the most important differences. Last one. Okay, pressure is a scalar quantity. Pressure is a scalar quantity. What is scalar quantity? The quantity which having only magnitude. The quantity which having magnitude only, then it is known as scalar quantity. The quantity which having both the quantity which having both magnitude and direction, then it is known as vector quantity. Okay, what is vector quantity? The quantity which having both magnitude and direction is known as vector quantity. The quantity which having only magnitude, then it is known as scalar quantity. Okay, the pressure is a scalar quantity. Okay, next one. What is stress? Stress is a tensor quantity. Stress is a tensor quantity. What is a tensor quantity? The quantity which having only magnitude, which is known as scalar quantity. The quantity which having both magnitude and direction, which is known as vector quantity. The quantity which having both magnitude, the quantity which having magnitude, direction and plane of application, that is the quantity which having magnitude, direction and plane of application. And plane of application, that is an important word, that is plane of application, then it is known as tensor quantity. The quantity which having both magnitude, direction and plane of application, that is known as tensor quantity. We know stress is acting in which plane, that is horizontal plane or vertical plane or inclined plane. We are clearly mentioned about that stress. Okay, depending upon the area, stress will be changed. That is, stress is equal to force divided by area. That is resistive force divided by area. When area changes, then the stress will also changes. Therefore, area of the plane is clearly mentioned regarding the stress term. Therefore, stress is a tensor quantity. The quantity which having both magnitude, direction and plane of application. Okay. Okay, that is the difference between pressure and stress. Okay, unit of pressure, point of stress. Okay. Next, we have to know some axis. Consider a circular member. Consider a circular member. Horizontal axis, vertical axis. Okay, this axis is known as longitudinal axis. Axis in longitudinal direction. Axis in lengthwise direction or longitudinal direction, which is known as longitudinal axis. This is the axis in transverse direction or lateral direction. Therefore, these two axes are known as lateral axis or transverse axis. These two axes is known as. Okay, in this case, we say some like that force is acting in longitudinal axis, force is acting at lateral axis or transverse axis. These terms are coming in this subject. So you have to understand what is longitudinal axis, what is transverse axis, what is lateral axis. Longitudinal axis means the axis through which the longitudinal axis, lateral axis and transverse axis. Longitudinal axis means lengthwise direction act ചെയ്യുന്നതാണ് actually എന്ന് പറയുന്നത് longitudinal axis എന്ന് പറയുന്നത്. Longitudinal axis. Next one lateral, that is the sideways, that is lateral direction, that is equal to lateral axis or transverse axis. Okay. Okay, then today we are dealing with what is stress, what is the unit of stress, what is the significance of stress, what is the difference between pressure and stress, what is longitudinal axis, what is lateral axis, what is transverse axis. Okay, next we have to move on what are the different type of stresses. Before going to different types of stresses, before going to different type of stresses, we have to generalize the stresses in two categories. First one, that is engineering stress. Engineering stress. Okay, stress is generally represented by the symbol sigma. That is engineering stress. That is what is stress? Stress is equal to resistive force developed per unit area. Resistive force developed per unit area. Okay, next one, true stress. That is sigma is equal to resistive force generated per unit area. Consider a body, an external force applied in the member, that is equal to F, and the resistive force generated in the member, that is equal to P. We know that under equilibrium condition, that is the resistive force is equal to external force, therefore F is equal to P. That is P divided by area, that is P is constant throughout the member. Okay, P is constant throughout the member, then the area will changes. Then what is the difference between this area in engineering stress and this area in true stress? That is engineering stress means that is resistive force generated per unit area. That is unit area is the original area of the member. That is the force divided by its original area, then it is known as engineering stress. And force divided by instantaneous area, that is instant to instant the area will changes. Okay, when load is applied, the member may be elongated or contracted. Okay, then its cross-sectional area will also changes. That is instant to instant the area will changes. In each and every instant, when we in each and every instant we are calculating the area, then it is known as instantaneous area, and corresponding stress is known as true stress. Okay, load divided by original area. If we taken the original area only, then it is known as, that is the engineering stress. In the case of engineering application, we are considering engineering stress. It is not practically possible to take instantaneous area, because instant to instant the area will changes. We cannot able to it is not practicable to take the instantaneous area. Instantaneous, the area will changes. Therefore, we are considering throughout this problem or throughout this subject that is dealing with the engineering stress. What is engineering stress? That is stress is equal to load divided by original area, which is known as engineering stress. Load divided by instantaneous area, which is known as true stress. Okay, there are two concepts, that is equal to engineering stress and true stress. What is engineering stress? That is resistive force generated per original area. Original area, that is known as, that is AO is equal to original area. Area, that is AI, that is equal to instantaneous area. Okay, that is the difference between engineering stress and stress. Okay, thank you.